What kind of questions did you see on 8G you would like me to go over?
Can you go over number 33?
You got it. Number 33. Okay. So they would like us to do P at -2 minus D at M at X plus 2 times G at 4. Ooh, that's got a leg extra to it. So I'm gonna, up above, I have P at X is equal to 3x minus 1. So we're gonna take care of that. I also have D at M at X. So I'm gonna say that D at X is equal to X to the 1/3. M at X is equal to 8, and G at 4, so G at X, which is X squared. Okay, so this is just a big substitution type of problem. Okay, so first thing I'm gonna do is let's take care of this right here. I want G at 4, so I'm gonna use this equation here. So that means G at 4, I'm gonna place 4 in for X. So 4 squared is 16. So G at 4, that's gonna be 16. So this is gonna be 16, and then we're gonna go 2 times that eventually. Okay, so plus, then I'm gonna do M at X. So M at X is this. So I'm gonna take this 8 and I'm gonna plug it into here. So that becomes 8 to the 1/3 power, which is the same thing as saying 3rd root of 8, which is 2. So this minus is gonna be here, but D M at X is just gonna give me an answer of 2. So we have -2 here. So -2 plus 2 times 16. And then P at -2, P at -2, I'm gonna take -2 and plug it in for X on the P equation. So that's gonna give me -6 minus 1, so that's gonna give me -7. So then I get -7 minus 2 plus 2 times that. Well, this is gonna give me 32. So I have -7 minus 2 plus 32. -7 minus 2 is -9 plus 32 is going to give me an answer of just 23. So there's an awful lot with that problem. You know, you're plugging in, substituting in a whole different bunch of different places. Is that okay?
Can you do 23?
23, you got it. We have G over F. And so they tell us that F at X is equal to 9x to the -1, and G at X is equal to X to the 1/4. Okay. So let's think about it, what a few of these things are going to be. So I'm going to take this, and that's my denominator. My numerator is this. Okay, so then we have to, before we move on, this is in the wrong spot. It wants to move upstairs. Okay, so being that was in the wrong spot, we don't have to worry about it. So my original domain for the bottom, it didn't really exist because this was moving up top anyhow. This would have been like saying the 4th root of X. So my original domain would have been from 0 to infinity, hard bracket 0 to infinity. That's my original domain. Okay, now I want to apply it to this. I don't have an X in the denominator. On top, I can change that to 4/4. So I'm going to add it. So that gives me to the 5/4 over 9. So my domain, so this is my answer here. And then my domain has to be at least what my original is, or it could be tighter. So 0 would still work because I'd have the 1/4 power. So it's still going to be hard bracket 0 to infinity. So this entire thing is the answer to number 23.
So I have just another question.
Yeah.
What's the difference of g of x over f of x rather than g over f? What's the difference there?
This is, we are being lazy. That's it.
Okay.
That's it. That's a great question. Yeah, we are being lazy. Other questions off that, my friends?
With 31,
31.
can you leave the answer as 1 over x to the 4th?
Well, let's take a look. Okay, so number 31, we have d at x, and d at x, they told us was x to the 1/3. And we're doing that over t at x, and t at x is x to the 5th. Okay, so this right now, looking at, so if I just had x to the 1/3, it's negative to positive infinity for the domain. If I had x to the 5th, it's also negative infinity to positive infinity for the domain. Because I now have something in the fraction, I have an x downstairs. The only value that won't work downstairs is 0. So my domain for my answer becomes this. And all that means is 0 is the only number that doesn't work. If I plug 0 in for x, I would get the 5th x, or 0 to the 5th power, which is 0. So that means I'm dividing it. So this became a more this is a more restricted domain than the original because it was dividing. Now, where I'd like you to go with this is you kind of want to isolate your x's. So I'm fine with the domain here. The domain's not going to change at all anymore. But what I'm going to do is I'm going to take this and I'm going to realize that's x to the 1/3 over x to the 15/3. Okay, x to the 15/3. And how I got 15/3 is 5 over 1, get a common denominator. Now I'm going to subtract. So I'm going to go x to the 1/3 minus 15/3, which gives me x to the negative 14/3, which then gives me 1 over x to the 14/3. So this would have been the finished problem. This finished problem has this as a domain. Okay. What else do you see, my friends? Anybody in the
15.
15? You got it. Number 15, we have f at x, which they told us f at x is 6x to the 3rd over g at x. And g at x is equal to 3x to the 1/2 power. Okay? So my original domains as they sit, the domain of this would be negative to positive infinity. The domain of this, not take into account that it's a denominator, but the domain of this is, that's the same thing as square root of x. Is going to be square bracket 0 to infinity. Okay, so that's the first step. So I was just isolating the individual things together. Now, with me knowing this, my domain has to be at least that, if not more or less inclusive of numbers. Now I'm going to explain that in a sec. So those are my two domains of my originals if I didn't have it as a fraction. Now I have it as a fraction, so I have 6 over 3, which is 2. And I'm going to realize I have this down here. So now this problem as it sits like this, and I'm not going to be done with the problem yet, because I have this here, this means my domain has to be round bracket 0 to infinity. And the reason it's a round bracket is, yes, I can have the square root of 0, but the square root of 0 is 0. If I have 0 in the denominator, that's a big no-no. So my answer is going to have this as a domain. This is my domain. Then I want to take care of my x's. So this is going to become 2x to the third minus half. So that's 6 over 2. So that's 2x to the 5 over 2. This is my answer with this domain. That's a little tougher to think about sometimes. So there's like two parts to the answer we're looking for. We're looking for the domain. Do you realize the restriction? And then we're also checking to see if, do you know how to take care of my, base values of x? Excuse me. What else do you see, my friends? We good in the hood? All right, so this is going to sound like a goofy question. I don't remember. Did I give you the notes for H?
No.
It wasn't part of that packet? Is that right?
Yeah.
I think we only have G.
So I didn't, hang on real quick. All right, friends, are you sure I didn't I thought I gave you 2 packets of notes. I thought I gave you G and H. Am I incorrect?
No, I have H.
Okay, so we
Have
did,
H.
yes? Does anybody not have H? Okay, so I think we have H in there. So let's go ahead and do H notes. So if you would get those out, if you don't have them, just take notes on a separate sheet of paper. So we're talking about composition of a function. Composition of a function means I'm plugging a function into a function. Okay, that's really all it means. So when we do plug a function into a function, you have to find the domains of the original functions first, and then the composition as a function has to have the least restricted domain, if not stricter. Okay, so let's take a look. So this is composition of function. I'm plugging a function into another function. Okay, so we read this as f of g of x. So the domain of H is the set of all x values such that x in the domain of g and g at x is in the domain of f. Okay? And you're like, what? Well, let's figure it out. Okay. Oh boy. All right. This is a lot to think about. So this is a big screen to think about. I think this looks a little bit confusing. So let's move on from this to the problem. All right. So first thing I'm going to do is I'm going to look at this. And I realize that's the same thing as 3 over x, which would have a domain of negative infinity to 0, 0 to infinity. So that's the first domain. Agree? That means I can't allow our x value to be 0. Okay? So my answer has to have at least that, if not greater. This one, because I don't have any fractions or anything, has negative to positive infinity for a domain. So one of them has a restricted of one number being the domain, the other one doesn't. So now what I'm going to do is I'm going to take, when I do g at x, I'm going to take this and I'm going to plug it in for right there, for the first one. So this is going to be 3 parentheses, -1, 2x minus 1. Then I have to realize, oh, okay, I have 3 over 2x minus 1. The reason that's on the bottom now is because -1, that the exponent being -1 means it wants to move down. So this means that x can't equal 1/2. Okay, so then my domain of this is going to go from, my domain is going to be negative infinity to 1/2, 1/2 to infinity. And that's fine. It fits within our parameters. We had one number that we didn't include on the original. We had one number that we didn't include on the composition function. Okay.
What was it there?
So that's the first one. Second one, we're going to still look at it knowing this domain, but I'm going to take this and I'm going to plug it in for x right there. So that's going to give me my g at x, which is that. I'm going to plug 3x to the -1 in, which is the same thing as 6 over x minus 1, which means my domain can't be 0. So that's the answer to number 2. Okay. Questions on those two, my friends? So when you're doing these, find the domain of the originals first. If there's restrictions there, those restrictions have to come in. So if we had one number restricted, we have to have one number restricted at the end. It doesn't have to be the exact same number. It just has to be one of the numbers restricted. And then the last problem is we're going to do f at x. Well, they told us f at x originally was equal to 3 to the x minus 1, which is the same thing as 3 over x. Okay. So now I'm going to take this and I'll plug it back into itself. So I'm going to extend my page a little bit. So I know I have a restricted domain where it's negative to this. That's the original. Now, if I take this and I plug it back in for x, I'm going to get 3, -1, and then I'm going to plug this in. Okay. So keep note, we had this restricted, agreed, on the original. So on this new one, I'm going to distribute this here and here. So I'm going to get 3 over 3. This 3 dropped down to a denominator. This -1 times -1 is +1. So I get x to the first. So the 3's cancel out. So I get x to the first. So x to the first, which is the same thing as x. Now, I can't undo this. So this has to be my domain. And that's a little bit complex to think about because if you have x just sitting by itself, it shouldn't have any restrictions. But because originally we had a restriction, then the answer has to have at least that restriction, if not more. Okay? Does that make sense, friends? That's a tougher concept to think about. Because, and it really comes down to, did you check your domain on the original first? If you checked it on the original first and there was no restriction, went negative to positive infinity, then your answer could also be that. If your original had a restriction, you have to have at least that restriction, if not greater. It could be a one number. It could be, like hard bracket 0 to infinity, something like that. So your answer would have to have that as well. All right, so here's another example. So I'm going to find the domain of this first one. This is the same thing as saying 1 over x. So my domain of this is negative infinity to 0, 0 to infinity. This one has a domain that is just negative to positive infinity. So I know I have to have at least that red domain restriction. Okay? So I'm going to take g at x, this, and I'm going to plug it in for x. So f g at x is x plus 1 to the negative 1, which is going to be 1 over x plus 1. Okay? So let's ask this. I had one number restricted. So I have to have at least one number restricted in the answer. It doesn't have to be the 0. What's going to make this denominator 0 here? What makes this 0? What number? Well, 0 doesn't work because 0 plus 1 is 1, so that works. So this is going to be negative 1. So x can't equal negative 1. So my domain of this one is going to be negative infinity to negative 1 to infinity. Okay, so this is the answer right here. This whole thing is the answer. So you're saying what the domain of it is. We had one number restricted in the original. We still have one number restricted in the answer. So then we're going to go the other way. We're going to take f at x. I'm going to take this x to the minus 1. I'm going to plug it in right there. So that's going to give me x to the negative 1 plus 1, which is 1 over x plus 1. And I can go back to my original because the only thing that's going to make my denominator undefined is 0. And again, the rounded brackets at the zeros, meaning it won't equal 0. And that's just as restricted as my original, and therefore it's good. We good so far, friends? All right, what else do I have? Oh, okay. So this is actually a problem. If you ever go out clothing shopping and you know that let's say you have a coupon that's worth a certain % off, and you get to the clothing rack that you find something and it has an extra amount off, you don't add the two together. They become composite functions of each other. So this is your favorite clothing store advertises having 25% off sale. And then you have a coupon for an additional 25 or 10% off. Okay, use a composition to find the percent discount. So it becomes 0.25 because that's 25%. Okay, and then we have 10%, which is 0.10. Okay, so let's think about the 25% off. So let's say our price is X. That's our price. So that means that I have 0.25x as the first one. But let's say that discount wasn't taking place. So again, the price over here is X, and then we're going to go 0.1x like this. Okay, so if we call this one f at x is 0.25x, and I call this one g at x is 0.10x. If I wanted to find f g at x, or if I wanted to find g f at x, it should be the exact same thing. Okay, so if I use this one, that means I'm going to plug this in to here. So f g at x is going to be 0.25 times 0.10x. I had the hiccups right now, excuse me. So I'm gonna go 0.25 times 0.10. So that's gonna be 25 times 10, which is 250. Decimals here, I have 4 decimals, so 1, 2, 3, 4. So it's gonna be 0.0250. That's FG at X. If I did GF at X, doesn't matter the way you do it, that's gonna be 0.10 times 0.25X, which gives me the exact same answer. Oh, there's an X there. And that's gonna be 0.0250X. So if you wanted to buy if there was a piece of clothing that originally was worth $100 and you got 25, it was 25%, so you'd pay $75. It was 10%, you'd pay $90. If you had the composition of the two, you'd go 0.025 times 100, so that means your shirt is 250 off. Yeah, so that's a composition problem. So you plug one into the other. So that's a lot of times people think when they go into a store, if they go into a store, if you see the 25 and the 25% off and the 10% off, they think, oh, I'm getting 35% off. No, you're getting a composition function of the two. So it looks like down here, they said, what would the sale price of an $80 jacket be? So I'm going to use my little calculator. So I'm going to go 0.025 times 80, because the jacket's 80. Hang on, I goofed up someplace. So 0.25 times 0.1, 0.025. Huh, where am I? I made a mistake up here someplace. I'm trying to find it. 0.25, I agree, that's 25%. 10% is 0.10. 0.25. Oh. 0.025 times 80. So if I do this math, that's 2. The jacket was $80, so 80 subtract the 2, so I got a $78 jacket. That's not right. Hang on, let's work it out the longer way. Okay, so let's say my $80 jacket, I got my 25% off. If I multiply that by 0.25, this is going to give me 20. Okay, so that means that the jacket would cost 60 if I just had that. And then if I take the other 10% off that, that's another 6. So my jacket would then cost, it should be $54. So I made a mistake here. So I'm gonna make that right. Let's question mark this. I think you could follow this reasoning down here. You take 25% of the first one. So that means the jacket would cost you $60. You're getting 20 bucks off. And then you take another 10% off that, which is $6. So you subtract 6 from your 60 and you get your 54. So that'll work there. I don't know how I made that error. We'll probably clear that up this week a little bit more. All right, so friends, let me stop sharing here. I think I know what my error was. Oh, Will's having computer problems. So let me just make sure I'm in the right spot. I'm in the right spot. Good. Share. All right. So far, so that means that when I see you on Tuesday or Wednesday, please bring that G in, and I'll give you the points for G. And then H, let's just take a quick look at H, see what we have to find here. So composition of functions. So find the domains of the originals first. We did that. We did that. Try this one, see how you can get that. And try those. So let's do, what do we say we do? Let me change this. I'm going to change this to evens only. For next time. Make sense? And then double checking, we had a quiz. I think somebody didn't take that quiz. I gotta see who it was. Costa, you have a quiz to take with me. Still, you keep that up?
Oh, did we take that in class the other day?
Yeah.
Oh, okay.
And then Isabella, when you coming back, Isabella?
So right now we're thinking next Friday. We just have to consult with my physical therapist. So I have a physical therapy appointment on the 4th.
Okay.
So if they give us the okay, then I should be able to come back on the 5th.
Okay. Do you need me to switch locations, do you think? It's okay if we need to. It's okay if we need to.
Probably stairs are a bit difficult right now, but I'm off crutches. I think the week after I'm supposed to come back, so
Okay.
it should only be for a little bit.
Oh, that's fine. Just will you give me a heads up when you're coming back? You have my number still, right?
Yeah.
Yeah. So just give me a call or just send me a text. Let me know when you're coming back so I know to move our class that day.
Alrighty, sounds good. Thank you.
Sound like a deal? So the rest of you, let's see. Isabella, you're in cadre B, is that right? Cohort.
Yeah.
Cohort B. So my Thursday, Friday group, not this week, but the following week, I might have a note up on the board telling you to go to an alternative location, okay? Sound good, everybody? Is everybody, let's see, what time we out of here? What is it, 48? So any questions for me, my friends? Everyone know what you need to work on for next time? Now,
So
go ahead.
I owe you 8F. Can I just bring both of them in tomorrow instead of emailing you a picture?
That's totally fine. That's works.
Okay.
Totally.
Okay, thank
Yeah.
Is it okay if I just show you 8F now, or should I bring it tomorrow?
Just bring it tomorrow if that's okay with you.
Okay, yeah, that's fine.
Perfect. Thank you. And don't be like one of my freshmen. One of my freshmen, they go to show me a picture of it on their phone. They're trying to show me and their phone's about that dark. I was like, make that a little lighter. Say like they made it like tiny bit lighter. Make that a little bit lighter than that. So then I could see it. And I'm like, that's page 3. That's something we did back in August. Oh, I didn't know that. I know none of you would do that, but sometimes some people are trying to pull a fast one on the stirrup. So just kind of goofy. So know that if you came across anything on the rest of the homework front that was due today, that I will check off tomorrow. If there's anything from that you want me to go over, that's totally fine. If there's anything from today's homework that I assigned today, if we want to go over, and we just have the evens only, right? So remind me that tomorrow because I'm going to forget because I forget so easily. But that's all I have for you, my friends. If you don't have anything more for me, have a great day. Take care of one another. Look forward to seeing you Tuesday or Wednesday. Isabella, I'll see you. Hey, Isabella, have you been able to find our stuff that I record for you?
Oh yeah, I've been able to find that pretty well.
Cool. So I'm glad that's working for you.
Yes.
And we'll take it when you are ready to take that test when we get back. I'm not worried. I'm not putting a timeline on you other than May. Would that be okay?
Yeah, that's perfectly fine.
Perfect. So we'll take care of you. All right, friends, get out of here. Have a great day. Take care of one another.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Bye. Cole, Annalee, Will, still on here?
Yeah, I got some homework to show you.
Will you just show me tomorrow?
Yes, I can do that too.
Perfect, works for me. Thank you.
All right. Have a good one.
Thank you, bub. Annalee, Will, still on here? Will, your computer back working or is it still getting goofy on you?